Dear students, today we are going to start with new chapter, that is probability. So let's learn the basic terminology of probability and what is probability exactly.
Come across number of situations which may or may not happen, and we are not sure of the outcome. For example, by just looking at the clouds, I can say possibly it will rain today, but it will rain or not sure. So there are many situations like that. So when we start calculating the possibility of something to happen or not to happen, if we want to calculate that possibility mathematically by assigning some value to it, that is called probability. So we are going to learn about it in my later videos. In today's video, I'll share with you some terminology associated with it. Like here, I'll share with you the three parts. I will share with you what do we mean by random experiment. So these are the basic terms associated with the probability. So the random experiment, very frequently used word, and outcomes, sample space, trial, events. These are very starting basic terminology. So let us see one by one. So starting with the random experiment. What do we mean by this random experiment? So the experiment which we cannot predict its result, but we know what are the possible result. It means it has more than one possible outcome, and you can say it is not possible to predict the outcome in advance. Let us see with the help of examples, right? So I am taking the first example here, tossing a coin. So when we toss a coin, we know that either head will come or tail will come, but before throw we cannot predict. So it means it is throwing a coin is a random experiment. Then there is another experiment, throwing a die. It is a cuboid shape and there are 6 faces, every face having a number 1, 2, 3, 4, 5, 6. So again, before throw, right? We cannot predict which number is going to appear. So it is also a random experiment. Then drawing a card from a pack of a deck, which has there are 52 cards. We play these cards with the different suits with different colors. And if, for example, we want to draw a card from it without looking at it, so we cannot predict in advance that which card I am drawing. So again, this experiment is random because we know what are the possible cards in it, but we cannot predict before doing this activity of drawing. So this is also a random experiment. Then we have one more example, drawing a marble from a bag. I have a bag. For example, in that bag, there are a number of marbles for different colors. And I just, without looking at, I want to draw one of them. Before drawing, I don't know which color or which marble I'll draw. So here again, this activity is a random experiment because we know about the situation that there are these many marbles, and these are the possible outcomes, but we cannot predict in advance. So all these situations, so if we cover, so you have observed that anything, any experiment or any activity which has more than one possible outcome and one cannot predict it in advance, it means we are dealing with the random experiment. Then there comes a term, outcomes and sample space. Now, obviously, when we are performing any activity or any random experiment, we get a result. So those possible results are called outcome. And when we list all possible outcome of that particular event or random experiment, we call it a sample space. So we denote it by letter S. So when you club all the possible outcome and write down within a set, it is called a sample space. Let us take an example. I am taking again an example of a tossing of a coin. So this is an experiment of tossing a coin. Outcome is head or tail, right? And the sample space is S is equals to H comma T. So you can use different symbols, but very frequently we use the letter capital S for that, and we use H for head and T for tail. So this is also a sample space. And similarly, if I pick the example of throwing a die, these are the outcomes and the sample space is 1 2 3 4 5 6. So we can write down, means all possible outcomes. And let us take one example of, let us find out sample space. Let me do this activity here. I want to find out the sample space of coin tossed thrice. It can be three coins drawn together or tossed together, or you can toss the same coin three times. So both will have the same sample space. So in the first throw, I'll get head or I'll get tail, right? Or for example, if I again want to do, this is my first toss, right? Either I get head or I get tail. When I take a second toss, what happened? Either first with head I'll get tail, or possible say head, you can write anything, or possible you can get tail, right? And or you can get first tail and then head, or tail with tail. So in the second throw you will get this thing. Now when we are doing third time, so maybe when head is going, it can give you again head, or it can give you a tail. Or other possibilities, when you are getting head with tail, maybe you get again head, or maybe you get a tail. So when you are having this toss, again you get a head or again you get a tail. Or you can say that when two tails are coming, maybe in the third throw you get a head, or maybe you are getting a tail. So in this three toss, we may get these possible outcome. I am using it with the tree because when the toss are increasing, then not to miss any chance, we can make use of this tree and we can write down the sample space like this. I'll just see the tree branch. It means one of the outcome is head head head, one of the outcome is head head with tail, and then we have a head tail head, then we have a head tail tail. You can write anything in any order. This tree is just giving us a very clear confirmation that I am not missing any of the outcome. So then we have a tail tail head, and we have a tail tail tail. Again, in, you know that in set you can write anything first or anything later, it hardly matter. Order doesn't matter over here. Matter is, are we writing all the outcomes or not? So there are 8 outcomes here, right? And similarly, when we discuss about, say, find the sample space associated with this example experiment of rolling a pair of dice. Now when we throw the die, we get these many outcomes. Like you can take two. See, the sample space remain the same. For example, either you question could be, what is a sample space when two pair of die is rolled, or when a die is rolled two times. So both will give us the same answer. So here one with one with two, one with three, one with four, one with five, one with six, or you can say two with all the six. So see, here again the point is not to miss any outcome. We can make a pattern like you pair one with all six, then two with all six, three with all six, four with all six, five with all six, six with all six, and this way you can write down the possible answer. So that is about the, there are 36 outcomes, right? So sometimes it is important to learn the strategy also, how should write down. And then we have a last part of this video is trial and event. Any particular performance of a random experiment is called trial, right? We are performing something, so it is called trial. And outcome or combination of outcomes are termed as event, denoted by is. When you collect some or some of them or one of them, they are called the event of that random experiment, and we can denote it by E or any other letter. So it is a subset of sample space. Let me take an example. For example, consider the experiment of throwing a die. Let the event E be getting the even number. Now when we throw a die, and we know that these are the possible outcome, and we want to find out what is the entries of getting even number. So either you get 2, 4, 6. And similarly, if a die is rolled and event of getting less than 3, so which of the following is the right in the same? So getting number less than 3, so this B option is correct. So this way we can talk about number of events of a particular experiment. Hope you have understood these three main terminology.
So students, now we will solve sums based on it. The first sum. Write the sample space in each of the following. Toss a 1 rupee coin. The sample space is H. It will be either head or tail. So possible outcomes are head or tail. So the sample space is always written in a curly brackets and it is separated by a comma, H comma T. A ball is drawn from a bag containing 36 red balls and one white ball. So what is a sample space? So S is a sample space equals to, in curly bracket, 36 red ball and one white ball. In sample space we write it only once, we don't repeat anything. So 36 red balls, so I will write red ball only once and one white ball, so white. So red comma white is the sample space. The third, 6 faces of a die are 1, 2, 2, 4, 4, 6. Roll it once. So here the numbers are repeated, but in my sample space the number will come only once. So my sample space equals to, in the curly bracket, 1. 2 is repeated twice, so I will write only once. 2, comma 4 is also repeated twice, so I will write only once. 4, comma 6. As in sample space we are not going to repeat any number, we are writing it only once. So my sample space is 1, comma 2, comma 4, comma 6. The fourth one, D. A ball is drawn from a bag of 3 red balls, 4 green balls and 5 blue balls. So my sample space equals to, there are 3 red balls, so I will write only once, red, comma 4 green balls, so I will write only once, that is green, comma 5 blue balls, so I will write only once, that is blue. So my sample space equals to red, comma green, comma blue. A slip is drawn from 10 identical slips of paper labeled 1, 3, 3, 5, 5, 5, 6, 6, 10, 10 in a hat. Now here again the repeated numbers are there. So 3 is repeated 2 times, 5 is repeated 3 times, 6 is repeated 2 times and 10 is repeated 2 times. But in my sample space the numbers will occur only once. So my sample space equals to 1, comma 3, comma 5, comma 6, comma 10. A spinner like this is spun. Now here a spinner is spun. So my sample space equals to A, comma B, comma C, comma D. The next question, write the sample space in each of the following. A regular tetrahedron of the sides of which 1, 2, 3 and 4 are written is rolled twice. Now here the tetrahedron of a sides of which it is 1, 2, 3, 4 are written is rolled twice. So my sample space equals to, S equals to, in the curly bracket, 1, 1, 1, 2 because it is rolled twice. So 1, 1, 1, 2, 1, 3, 1, 4. Now I will start with 2, 2, 1, 2, 2, 2, 3, 2, 4. These are the all possible outcomes. 3, 1, 3, 2, 3, 3, 3, 4. And the last 4, 1, 4, 2, 4, 3 and 4, 4. Curly bracket close. These are the all possible outcomes when a tetrahedron of side 1, 2, 3, 4 written is rolled twice. The next question, draw a T diagram for the sample space of a ball to be taken out from a bag with one red and one green ball taken out 3 times. How many times it is taken? 3 times. The ball is put back after each draw. Now we have told to make a tree diagram for the sample space of a ball to be taken out from a bag which contains one red and one green ball, and it is thrown how many times? Taken out 3 times. So I have to draw the tree diagram for it. So the first time it has come red and here it has come green. Now when I draw with second time it will have outcome red or green. So when I draw third time here, it will have the outcome red or green. Again red or green. So my sample space here it is R, comma R, comma R, R, comma R, comma G, R, comma G, comma R, R, comma G, comma G. These are the all possible outcomes. Now here again when I toss it, when I taken out it for the second time, my outcome will be red or green. So R, G. Now when I toss taken out for third time, again we have how many outcomes? Two outcome possible. Either it will be a red or green ball. So here when I toss it for the third time, here again it will have a green or red ball. So my possible outcomes are GRR, GRG, GGR and GGG. So these all are the possible outcomes. How many outcomes? Total 8 possible outcomes are there. The next question, list the sample space and all the simple events for each of the following. Draw, throw a regular tetrahedron color on each side, blue, green, white and red. So my sample space is blue, green, white and red. So sample space, what do you mean by sample space? It are the all possible events. So my sample event is blue, comma green, comma white, comma red. These are all the possible outcomes. Draw two balls from a bag containing one red, green and blue ball each. So my sample space is draw two balls from a bag. So I have to draw two balls from a bag which contains one red, green and blue. So my sample space is red, green, the first ball. Then it will have red, blue. So my second outcome is red, blue. Now I have told to draw how many balls? Two balls. So again it will start with green, green, red and green, blue. And the last one it will be blue, red and blue, green. These are all my possible outcomes for the sample space when a ball, two balls are drawn from a bag. Sample events. Event are the individual or possible outcomes. So red green, comma red blue, comma green blue, comma green red, comma blue green, comma blue red. Draw a slip of paper from bag containing slips of paper with 2, 2, 2 and 5 written on them. So my sample space is 2, 5. Here 2 is repeated 3 times but I will write only once as repetition is not allowed. So my sample space equals to 2, 5 and my sample event equals to 2, 5. Draw a marble from a bag containing 8 green marbles, 10 blue marbles and 6 red marbles. So my sample space equals to green, comma blue, comma red. I will not repeat any color twice. So my sample space equals to green, comma blue, comma red. And my sample event is the possible outcomes of the sample space. So it will be green, comma blue, comma red. List all sample events in a slip of paper is drawn from a bag containing slip of papers with 1, 2, 3, 4, 5 and 6 written on each respectively. Is 1, 2 an event in a sample space? So my sample events are 1, 2, 3, 4, 5, 6. The sample events are the possible outcomes from the sample space. So here is it 1, 2? No. So my 1, 2 is not an event element on sample space. State which of these are simple events. 3, 2 for drawing. 2 slips from a bag containing slips label has 1, 2, 3, 4, 5. So Yes, this is a simple event. 3, comma 2 is a simple event. We can draw this 2 from a bag. 4, comma 4 for drawing two slips from a sink bag has in A. So can 4, comma 5, 4 is not a simple event because cannot draw two fours at the same time. Replacing of slip is not mentioned. So we can't draw 4 twice. 3, comma 3 for drawing two slips from a bag containing slip labeled as 1, 2, 3, 4, 5, 6. So here we can't draw 3, comma 3 twice. So this is not a simple event. Drawing an odd number from a bag which contain 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8, comma 9, comma 10. Is it possible? Yes, it is possible to draw an odd number from a bag which contain this number. So it is a simple event. So students, I hope you all have understood the content. So there is a small assignment based on it. Please try to solve it. Thank you.